Just fold to the title. You don't necessarily have to cut these. That's totally, one fold will be fine for this one. And so you have simplifying radicals, exponential form of radical form to exponential form, and simplifying radical exponents. Okay, so when we started our radical unit, we talked about the number that's inside of here is called your index. We already know the number under here is called your radicand. And of course, this is the radical itself. Okay, so we just know because you got to know the parts to a radical. All right, so obviously we know how to simplify them. Okay, 7. Okay, when they're perfect squares, you don't even really have to break them down like they did. So now, what does this mean here? That means what same four numbers can you multiply together to get 81? So 3 times 3 times 3 times 3, okay, obviously is 81. So these are all perfect in here. Same thing here. So the index is very important because it just simply asks you what same 3 numbers can you multiply together. This is a perfect cube. It would be 6. Okay. So we're going to run through this part fairly quickly. Again, what same 5 numbers can you multiply together to get 32? And the answer is 2. Okay. So that's what the index tells you. How many times you're multiplying the same number together to get the number under the radical. All right, so now we're going to take a fraction, exponent, and we're going to write it as a radical. So that means this number that's in the denominator becomes your index number. And then here's your base that stays here. And then the number at the top will be your exponent. Okay, so let's see how this works. So here you have d to the 5/6. So that means the 6 is the index, d is your base, 5 is your exponent. Okay, so just knowing where to place the numbers. Next one, that means 7 is the index and 2 is the exponent. The base is still e. Okay, next one, 3 is the index, and then m to the 2nd power is the radicand. All right, now let's say you want to go in reverse order. So they give you this, and now you have to turn it into a fractional exponent. Okay, so if you have the 5 here, remember that's your denominator. The exponent that's under the radical is the numerator, and the base is the base. So y to the 3/5. So if we're looking at this, we will say g to the 4/3, sorry. Okay, your index is in your denominator. So I think you can kind of see the pattern here. So remember the invisible index is 2. So you have r to the 7/2. All right, so let's take a look when you have some numbers. So if I have 125 to the 1/3, that's going to be the cube root of 125, which is 5. And you don't even need to say 5 times 5 times 5. Since it's a perfect cube, you can just simply say equals 5. Okay. So this one would be the 4th root of 16. So what same number you can multiply together 4 times to get 16? And that number is 2. And then the last one, okay, we have the cube root of 27 squared. Okay, so really, since the cube root of 27 itself is perfect, you just square 3. 3 squared would be 9.